As Randy shared, I'm going to be discussing SIZER today. And can you see SIZER, Randy?
Yes.
Perfect. So what SIZER is a free to download software from Siemens that allows you to build the perfect system that you need, your motors, your drives, all your cables, accessories, everything you need for your new system. So today I'm going to do a quick demo. Let's pretend that I have a rewinder machine and I want to size my unwind axis. I need a motor and drive for that. So I'm going to go ahead and start a new project. If I had another project that I was previously working on, I can easily get to it just right here in the open project. Or say I wanted to just see a demo that Siemens has already previously done, I can actually just click SIZER demo projects up here and it comes automatically downloaded with the software, so you can check that out. But today I'm just going to name my project for our Digital Software Summit, and I'm going to create my project. When the software first opens, you're going to get an explanation of these 4 tabs in this upper left-hand corner for all the things that you can do in each. So today we're just going to quickly run through each of these tabs. The first we're going to start with is our mechanical system. I'm going to add a new mechanical system, and for my unwinder, I'm going to choose my axial winder mechanical system, and I'm going to name this my unwinder. I'll select OK. And then when I go back into this, this is where we start getting into the good stuff, all of the values that SIZER asks for. Let's say I don't have these values offhand. I can actually export a checklist right here, and I can email this to whoever can help me out to get these values to input. And let's say someone on the team has a question about what one of these values means. There's a helpful help box that you can go to, and it gives a description of what the value means and why it's needed. So I'm going to pretend I got my checklist from my team, and I'm just going to start importing my values. So here you can change your unit. I'm going to say that my material mass at full load is 200 pounds. And the next they ask for is the inertia of the core. This is the one the team had a little bit of trouble figuring out. So I'm going to go to this calculator up here and calculate my moment of inertia based on some other values that we do have. So let's say that I have a hollow cylinder. And rather than mass specification, I'm going to choose density. My outside diameter is going to be 3 inches. My inside diameter is 2.5 inches. And my height is 30 inches. My material that I have is steel. And we're good to go. I will calculate my data. And here's my total moment of inertia of my core. And so when I click OK, that value is automatically input there for me, and we're good to go. We're going to say that this is a simple system and we don't have any other inertia to consider, and we'll move on to the mechanics tab. The maximum winding diameter is going to be 3¼ inches. And the maximum winding diameter is 36 inches. We have a flat material, and we have no additional friction torque with the full coil. And I'll click next. Let me just make this a little easier to see. So here now is our traversing profile. Are we working on our unwinding or our winding axis? We're working on unwinding, and we don't have a flying splice. When my roll is completely done, we're going to manually put some new one on. And my material thickness is going to be 0.02 of an inch. And let's say my material velocity is going to be 500 feet per minute. What's cool about SIZER is I can actually input different values here, and it's going to convert and calculate for me. My maximum tensile force will make it 48 pound-feet. Acceleration time we want is 10 seconds, or sorry, 5 seconds. And our deceleration time is 10 seconds. Our pause time before winding will be 0 seconds, and we'll take about a 5-minute break after the winding, and we have no additional tensile force. And now I'll finish. So now we have an unwinder axis, and we're done with this mechanical systems tab, and we can move on to the drive system. Here I'll add a new drive system. And the first thing I like to do is go to the new supply node and confirm that this matches my input voltage that I will be using. And I like to name it as well. So I'm going to say this is my unwind axis at a motor only. And I'll leave all these values as default, and I'll click OK. One of the tricks with SIZER is it's extremely helpful in helping you pick out the products you need, but you do need to have some idea of what products you want. So for today's demo, we're going to make a Dynamics S120 servo system and match that with a Dynamics 1LE motor and an incremental encoder. This S120 system will consist of a PM242 power module with a CU310 control unit. There's two reasons I'm picking these products, and the first one is because it's modular. So if I ever needed to replace my power module or my control unit, I can do so without affecting the other component, save cost and time. And the other reason I'm choosing this is because this control unit has what is called winder DCC, or drive control chart. And this means that this control unit can actually handle all of my winder control without the need for a PLC, and I can remove that component from my project. A compact flash card is required with this control unit, so SIZER will make sure we don't forget it. And then I'm going to add an optional operator panel as well. Let's go back to SIZER, and I'll show you how I select this system. I'm going to select that it's a single drive, and here's my S120 system, and here's my 1LE motor. Now, I'm going to say I want to select my motor based on a mechanical system, and this box will pop up. And from here, I'm going to go ahead and select that unwinder axis system that we just created. And so for my unwind axis, I want torque control for tension control. And that uses the same algorithm as vector. So I'll change this to vector. And when this pops up, you'll see this with or without pulse edge modulation. This is a bit unique to Siemens and can help you fine tune your vector algorithm. And we can review this further in the breakout session if you're interested, but I'll leave it at default for now. And I'll select OK. Now from here, we just move on to the next box. So let's dimension our motor. I don't want to add a gearbox right now, so I'll select next. And so here is the actual motor profile that we created by entering our mechanical system and all of our requirements. And so this is how SIZER is going to decide what motor is best for us. I'll select next. And here we see our effective torque and speeds. And here we have the option for when we choose a motor. I always recommend changing this to at least 90%. Give yourself a little bit of wiggle room for thermal utilization and torque requirements. Then I select next. You can have a few more options here to filter down motor options. I don't need a brake or anything like that, so we'll just select next. And here is where SIZER tells us all of the hundreds of thousands of motors that could technically work for our application. And it looks mildly daunting. So my favorite thing to do is go to the determine optimum motor and choose according to load current. And I just let SIZER determine it for me. It knows the motors better than I do. So right now what it's doing is it's calculating which of these motors is actually the best fit for the specific mechanical system that we made. It takes a few minutes, but I shouldn't have to do yep, there we go, we're good. So now you see we get a little thumbs up right next to this motor. So I'm going to go with this one here, and I'll select next. And here's where we can double check all of the specifics and if this motor will really work for us. This little light bulb here brings us to what was checked to determine this motor on this chart. Notice that we're at 88% thermal utilization and 30% torque, so that's below the 90% we requested, so we're good to go. But notice that our external moment of inertia to our motor moment of inertia is red at 36%. This means that it's possible to use this motor, but when we're first setting up our vector speed control, we're going to have a little bit of trouble fine-tuning that specific speed control because of this inertia mismatch. So in the breakout session, we can go over different ways that we can improve this mismatch. But we'll just go ahead in this demo with this motor and select next. And here's where you can add some other stuff to your motor. The only thing I'm going to add here today is we're going to add an HTL encoder for our speed control. Click finish. And now we have our checkbox next to our motor. So we'll move on to our power unit. And here's my very favorite part about SIZER. What it does is, so now it knows from the specific motor what torque and duty cycle that it is required of it. So it knows exactly how much current that is required for that motor. If I just pull up real quick the motor spec sheet, notice that this motor that we're using has a nominal data current of 34 amps. But if we go back to SIZER, I only need 20.8 amps. So SIZER is allowing me to actually downsize my power module to exactly the size that I need. So we can choose this 26 amp one rather than say this 38 amp one to make sure that we cover the continuous 34 amps, right? And here you can go to the info button and see all the things that were checked to make sure that this power module would work for us. And I think this looks great. So I'm going to choose this one here and click OK. And next is the braking resistor and the braking module. For our unwind axis, our motor is going to act like a generator because we are going to be counteracting the pull to keep tension control. So we will be regenning, and we do need a braking resistor to capture all that regen before it reaches our power module. So SIZER has calculated exactly what regen will occur and has recommended the specific braking sizer for us. And we can confirm here that we're good to go for constant power and for peak power. And so I'll add that to our project. Now we have our green check at power unit, and we'll move on to output components. If we had long cable lengths, something like that, we can add output choke. And next is our power cable. Here, my first recommendation is always remember cables have ambient temperature readings just like all the other products. So here you can actually choose your ambient temperature, and the applicable D rate for your cables will occur. Defaults at 10-meter length, but you can change that if you'd like to. And there's a few other options for you that can help you with your cable connections. If you had an external fan, you can add this here. For now, I'm just going to add that I would just want this 10-meter power cable to my motor. Select OK. And then for my encoder, I do have this encoder, and so I want to add a cable to that as well. I'll leave it as 10-meter length, just like the power cable, and I have the same options here as I did for the power cable. Say I'm using a secondary external encoder, I can select that here and take that cable into account. Select OK. Now we've got a green check at our output components, and so we've got one step left, our system components. So we move here, and we'll click to dimension our input types. Every Siemens drive requires some type of circuit protection, so we're going to add our circuit breakers here. If we wanted a line choke, we could add it here. I'll select OK. Next is our control. When you click this here, it actually opens up a section for you in the left-hand corner over here. And if you double click, now we have kind of a similar looking checklist like before. And so here it's asking us what control unit do we want to use. And it's defaulted to the CU320-2 DP, which is Profibus. I don't want this control unit because this is actually a multi-axis control unit. And for this demo, I want a single axis. But what's really cool is notice with this multi-axis, I have this one drive system I've used, and it's using 37% of this control unit. So you can see how with the multi-axis, this will actually help you determine how many axes you can have on a single control unit. For our breakout session, let's add our rewind section, and we'll change to a multi-axis and go over this further. But for now, I'm just going to change this to a single axis Profinet control unit. And I'm going to add my basic operator panel with this checkbox here. And so next box here is what about all of my I/O on that control unit? Does it meet my needs? Here you can see what's on the control unit defaults. And you have these options to add more terminal modules if you need more I/O. So for this example, let's say that I need an analog output. So I'll add a terminal module 31. And so then you can see, here's now I have 2 analog outputs in this system. And then as mentioned before, the control unit requires a compact flash card to work. And here is SIZER showing us that it's been automatically added to our bill of materials for us, so it won't be forgotten. And we'll click OK. And so the next step is the installation arrangement. This is specific to when you have a multi-axis system and you're working on your topology. So we'll just click OK for now. And then we'll go to our drive click or our cable topology. How is our control unit and that terminal module we just selected going to be connected? So here we have our default wiring to the terminal module, and I'll select next to select the cable. I'm just going to choose a standard cable, and here I can choose my length, whatever I would like to use, up to the maximum of 70 meters. I'm just going to say that this terminal module is going to be right next to my control unit in my cabinet, and I'll just choose the shortest cable available. And I'll select finish. And next is our 24-volt power supply. The control unit operator and power operator panel and terminal module will require some power for the internal electronics. So let's make sure for our input voltage, we'll choose a 460 volt power supply. And here I'll go to optimize. And I'll say I want the smallest possible power supply for all of my project components right now. So it's added up all of our current requirement. We need 1.32 amps, so it's recommending the SiTop module 5 amps. So we'll select OK to add that to our project. And so now we're technically done, but we do have this additional component section. So say I had an external component, like external encoder or a PLC that I already have that I'm going to use in this project, and I just like it involved in this project, I can import that here. But for this, we'll just say that we're done with our demo here. So I'm going to go to this box and display all my technical data, and you can confirm everything looks good here. If it does, then you can go to Tools, and you can choose Export Project Documentation. And when you do that, it will actually output a Word document for you of all of that technical data that you just confirmed. It shows you the cabling topology that has been selected. You can scroll down, you can see all of your motor curves, specifically what loads you're expecting. Pretty cool. And then right at the bottom here, you get a bill of materials for your project. And the position that is listed here is actually applicable to all of the documentation above, which is pretty cool. So this is kind of a one-stop shop project. And I think it's pretty cool. What do you think, Randy?
I agree with you.